Yes. All right, we'll go ahead and get started. Make sure this is. Yep. So today we're going to continue our discussion on the Internet of Things protocol. And the last time we talked about the Modbus. We're going to recap that. We had a lab that started using the Modbus last semester, last class time we met. Some of the groups got finished, and we will have time to. If you did not finish that lab, we will have time next week to complete that and then tidy up the report there. I think a lot of people got the read code, but when we come into holding registers, it's a 16-bit value versus a single-bit value. I think some people are still working on sending maybe something back besides the single bit through the holding registers. So we will have, so today we will talk about the MQTT, and then next week we'll have 2 lab sessions back to back. On Tuesday, this lab may take 2 sessions. Last year we took the whole 3-hour block, so you'll have time to complete the first lab and get started on the MQTT, and you do not have to finish it on Tuesday. We will resume it and finish off on Thursday. So you could feel free to leave at the allocated time the class, and then we will complete it with Thursday. And I move the due dates accordingly to when people think they're ready to submit that report there. And so remember, I'm going to be out next week, at least the beginning on Tuesday. I'm not sure about Thursday. I'm still looking at my return flight there. But if I'm here, I'll probably be back before the lab, so I will begin there on Thursday if I'm here. Nothing gets delayed. So this lecture, I am recording this one by request. Will be useful for completing the next lab there. So we're gonna go ahead and get started. All right, so we're talking about the Modbus, and remember, Modbus allows you, there's a master and there is multiple clients, and a master is going to initiate the conversation, and it can send information over TCP/IP. But it originally started over serial port, and there'll be a fixed packet size, and the clients, which they call slaves, is able to receive look at the address bit and take the information, and then it's going to send a knowledge back to the master saying, I've got your request, and it's going to keep going in the circle there. There are disadvantages with it. It's a fixed payload size. They have security. It has everything else, but you can only talk to a master and a client. So if I want to communicate with everyone in the room, there's no way to broadcast that message. The master will have to send a message to each one of the client and do something. So in a control system or autonomous environment, you may want to have multiple machines on the network, and you want to say, okay, all the CNCs shut off, all the e-stop, turn everything off, or get sensor data from multiple rooms and put them together. And this is where the MQTT is going to allow you to do, is going to be able to connect to multiple clients, to multiple systems, and broadcast messages. And if you're interested in that information, you can subscribe to it. If you're not, you can just let it go, and you'll be able to do more distributed sensors, so systems using the MQTT protocol, and there's other protocols as well, but these are the 2 that we're going to focus on in this course here. So after we do these labs, and then we're going to move on to the industrial robotics and starting with frames there. But this is just talking about, there's other EtherCAT and some other things that we're not going to talk about, but there are other protocols out there. And so the Modbus single slave, single master, multiple slaves, and they have a fixed packet. You have the address, you have the function code. The function code, remember do the recall and the write. Those are the functions. And you can do read registers, write registers. So those are the different functions they have. Then you have your data itself, and then all of these have error CRC bits to know that you sent the data didn't get corrupt over the network. So that's one advantage with these there. And then it gets sent back. So there's always a knowledge packet is sent back to corresponding to the query. So the query and response should have some of the similar data coming back there. In the labs, you discovered there are certain registers where these go. So if you add booleans, which is the single call, they start with address the 000 and then the appending from 1, 2, and 3, and 4. And that's how you was able to set the inputs and outputs. If you want to turn on a motor or stop a motor or look at a sensor IO, just a single boolean value if it's on or off, true or false, you can use the input call there, and you could say force this thing on or force this off there. But it's only a single bit. If you want to send more rich information, such as the string, a time, a status, you need to convert it to a 16-bit number. And we talked about the conversion thing, and that's a way allow you to send more rich information back and forth there. And they're gonna start at a different address though. They're gonna start with the 3000s for integers and 4000 for the floating point numbers. But they're still 16-bit numbers, and you will have to typecast that into the correct format to actually use that. And so when I asked in the last lab to send back the counter value, for example, it's not a boolean. It's going to be a integer number, or it could be a real number. It's because integers is counting zeros and ones. There's no decimal places, and you can use a holding register to send that information back there. But it's a time value. You need to get it into an integer, so you need to do some kind of conversion to typecast that over, and then you can do the read holding register to get that value back into your client environment. And in this case, we use either MATLAB or Python as our client library to support that. And so you have to do some initial configurations, and it doesn't necessarily have to be these elements here, but this is what the holding register is. Much memory allocated for the integers, a 40 array, and a real is a 30 array. And these will map this in using the PLC environment. And this is just some examples how we did that in the last class. And this is really important, is the Modbus mapping. So once you have those global variables, it could be named anything you want to. The communication protocol doesn't know where to assign it to you to this mapping. And so it's going to assign these addresses, starting with the 4, to the holding. So that is the address, but it's actually holding register 1. It's assigned to that address. 4,000 or 40,001 and et cetera there. And that added some additional registers that you could set directly. And I showed you an example here of setting a switch, 2 switches. This is a start and then a stop. And we latch that and we use a motor. So all of these are booleans. So I didn't have to do any kind of conversion to make this work there. And we kind of demoed this here. And I'll also show you some Python code, some example code to how to do the holding register, the 16-bit values, and then I also showed how you do the single booleans, the on and off. And this example, I'm enable the system and I disable the system. So 1 is true, is enabling something, and then a 0 is disabling the device on that Modbus. And you just need to know the IP address of the server running that particular system there. So any questions on the Modbus? Oh, all right. So MQTT, I gave a brief intro into that in the last lecture too as well. Today I'm gonna give a little bit more information, and then I'm gonna show you an example in Python as well as an example of running it on the PLCs. So this is what you're going to be used to actually complete your labs next week here. And we talked a little bit about the background. I'm going to kind of skip through that again and get to some of the meat of things here. And so the difference, the MQTT again, you have the server, which they named the broker. And so that is where everything can connect to the broker, and you can have many clients subscribe or publish to that broker. So you have a man in the middle, and everyone is kind of talking to that, but he's sending that information to anybody else who wants to listen to that. So if I am publishing information, I'm sending packets, which is going to be called topics, to the broker, And if I'm interested in that topic, I can subscribe to that or as a sync and I can receive that particular topic there. And it's also a very lightweight. There's other protocols that do the same thing. Like DDS is one that I use a lot of, but this one is a very lean protocol that can run on very tiny systems, even the Arduino, versus some of the other ones that need a little bit more CPU to actually do there. But it has everything says quality of service. We're going to talk about that today. And it also has encryption, security keys, public private keys, and everything to do a lot more rich things with there. And so the advantage of this is I could talk to many people at a time versus a single conversation. And this is what makes this a little bit more richer than the other particular systems here. So in this figure here, you have message A and shared to anything on the same network. They have to have the same subnet, and then they can be able to receive that here. And so there's different ports. It is a server. And there's certain, these are the default port settings. 1833 is default if you do the normal installation there, but it does support encryption, authentication. By default, there's no username and password, but you can set up, it's just like a regular server. You can set a read and write access and who can talk to what data, and you can have public keys, private keys, and certificates and all that as well. And that would use a different port number, and this would be all in your configuration. More information that go to this website and they can give you some things. But in this class, we're using the public broker, which is the testmosquito.org, or I show you an example how to create your own broker on your own laptop or own edge computing device, whatever you want to have start to send information back and forth there. And so we're using port 1883 by default, which is unencrypted, unauthenticated. So I don't need any username and password. I don't need any security keys to actually talk to that server there. So this is just some information to how to streamline that communication there. So there are, you still want to keep the payload rather small, but I can have up to a single packet up to 256 megabytes now versus the kilobytes that I had before. So I can have a lot more rich information, and I can control the way that data looks there. So I can have a JSON format, it could be in a raw format, it could be in an XML format, but I could and I can give it labels and things there. And so in this class, I'm going to use JSON message to describe my data field and send that back and forth to there. It still has a fixed header, but it has variable header and variable payload, which is the difference between the MQTT and the Modbus. That was a fixed payload and a fixed header size. And now we can have, so depending on the payload size is how much actual traffic is going to be on the network. And you could, if you have a low bandwidth network, you can control that as well. And we also could have this thing called quality of service, which I'm going to talk about in a second here. This here is going to be, the next couple slides are more for reference, but you will see these coming up later when we actually do demonstration. Just like any,
I was just going to ask, is there any benefits to using Modbus over MQTT?
Not necessarily. It's really what equipment supports what protocol. And since the Modbus is one of the oldest, it's going to be on more devices by default.
Okay.
And then, especially the older devices.
Okay, so this is like a newer.
It is newer, and you can find MQTT on a lot of devices as well. But you can pretty much guarantee if it's an industrial system, it will probably have a Modbus. But yeah, if I had both, then I will probably use the MQTT over that. But Modbus is just really simple too as well.
Okay.
And so this is just some background reading information. But yeah, of course you have to connect to the server, and we're going to publish things and subscribe things, and you can disconnect, and there's a knowledge bias that comes through here. And so just keep these next couple things for your reference. You can give it usernames and password. That's something you wouldn't be able to do with the Modbus, is you just connect to over the IP address, and you don't know who's really getting the information from who. So now I have a little bit more control of the data, and it gives you a little bit of some timestamps. Who's the last time that this data was accessed and things. So there's a lot of metadata that's available now. And there's return codes that you can kind of debug things a little bit, where this is coming in handy a little later. One of the things I do want to bring out is the quality of service. And so we could know if that information is actually getting broadcast to you. So if I have something critical, like emergency stop, you may want to guarantee that you receive that message. If I have something like this is the temperature, if you miss that data, it's not necessarily important to your system there. So if you want real-time information, you may want to change the quality of service, which is important to guarantee the information gets received. If you don't really, if you like to have information but not necessarily critical, then you might want to use the lower quality of service of 0. So you have 0, which is unreliable but is very fast. And so that's like any sensor just broadcasting something. I default to 0. A 1, you'll guarantee if I really want to get that information, I would use 1, but you may get the information twice, maybe duplicates there. So if it doesn't receive the first time, it may try to resend that, and you may get both messages. And then the quality 3 is this guarantee exactly 1. So if it's an e-stop press or something crucial in your system, and I want to know everybody connected to it receives that message, I may want to move my quality of service to a value or 2 there. And there's also return codes there. So this is it again, but in the next slide is going to be a little bit more detail here. So the quality of service is 0, which is the default here. We have the broker in the orange. You have your publisher or your subscriber, and it's going to the publisher is going to send something to the broker because remember this is the man in the middle, and it is going to distribute that information to anybody who's subscribing to that. So this packet was sent to the broker, and the broker just repasses it out there. If the client was not listening at that time period, he may miss that information. So if it's polling, he may miss that information. If it's an interrupt, he may have received it there. And so you fire it once and you forget about it. And if you missed it, you just missed the information. A quality of service 1, I'm going to send the information to the broker, but I'm going to keep that information for a little bit of time. And so if it's missed, then I can republish that information back. And so I may get that message multiple times, but I know that someone who wants the information will at least get it at least one time. And then the quality of the service is both the broker and the publisher is going to retain information for a little bit of time and kind of guarantee that information gets to you in some time. So there's a little bit more handshaking involved as your quality of service increases from the 0 to the 1 to the 2 level there. And so this is the default one. Publisher, I'm going to connect to the broker. I'm going to get a knowledge back, and then the subscriber is going to connect to the broker. And then once they both talking to the broker, the man in the middle, I can publish the subscriber information here. And that information is going to be called a topic. And so here, for example, I have the topic is called Home Alarm 1 status. And so we like to prefix it as much as possible so we can kind of break down, so people who are subscribing to it know exactly what they're looking for. So this is probably some kind of home alarm system, and this could be the room number, and this could be, okay, room status is true or false, so that means that alarm in that room may be false, and I could have a room number 2, and so on. So this will be the topic, and I can have multiple, I can enumerate the topics. So if I have multiple rooms, I can have 1, 2, and 3, and so on and in. And I can use a thing called wildcards, which I couldn't do in the other there. So if I want to subscribe to all the home alarm systems, I could subscribe to the home alarm and I could put in some wildcards as a hashtag or the star, and I could get everything that's there, or I could get that specific room information. So it's up to the client to figure out how they want the information there. And so this is some examples of absolute topics, such as the temperature in room 1 and the pressure in room 1. And I have 2 rooms, 2 sensors in each room, and they are broadcasting to the broker. And if I'm interested in connecting all the sensor data in this entire building, I can subscribe to each different room and get the information, or I can subscribe to sensor plus, and this would get the temperature in all the rooms and as one single packet. So you can add this wildcard called the plus here. Or if I just interested in all the sensors in this one room, I could just put the wildcard in different places here. And so this allows you to get kind of a unique way of getting the different topics back here. So That is one advantage is using wildcard, and you cannot do this in some of the other viruses, the DDS. You have to get the particular topic only. Yes.
So for the first one, you put a plus before the temperature, so that will give you all the temperature data all of the temperature.
That's correct. So whatever the pluses will be the whatever is going to listen to all anything in between. So the wild card. So and we happen to have room 1 and 2 and so on in there. And so you're going to get the temperature for everything in the room. And for here, this is going to the plus is after it. So I'm going to get both temperature and pressure for room 1 and the second example. And this one here has a hashtag, so it'll only get room 1 temperature, room 2 temperature, room 1 pressure, and I don't get all the data is available. And so this is great for distributive sensors or distributed automation. I could have this MQT, all my sensors on all the CNC machines or whatever, to sending out data. If I want to get information on one particular machine, I can subscribe to that one particular machine. But if I want to know what all the temperature on all the machines in the building is, I could do a wildcard and it would give me every single temperature of all the machines there. And then you could put this in the database and then you could go from there and do some different things on that information. And so that's how the wildcards are useful for machining things. If I use my bus, I would have to go and talk to each one of the machines and say, hey, what's your temperature? What's your temperature? What's your temperature? What's your And so it's going to take a long time to go all the way around the room and get everybody's data. If I want to know with MQT, I can say, hey, what's your temperature? And everybody's going to report back their temperature, and I'm going to just store that. And so we talked about this last class. If you want to install the broker, it's pretty simple in the Linux environment. They do have Windows version as well. You can just do a sudo app there. And this would start the actual service there. Well, if you wanted to start automatically and restart, you can make a service, and then this will be always running in the background of your system there. So this is an interesting command there. And Mosquito is one of the original authors of the MQTT, and there's other versions of MQTT as well. They all have the same protocol. They just have different names, but this is the one I'm using today for the demo here. So I have a broker running on my Linux environment in my VM on my machine there. And there's broker, but there's also public brokers on the, and that one is at test.mosquito.org. And there's brokers all over. You just got to have IP addresses on it and be able to communicate with that and talk to it. And so if this is just more useful information, if you this is using the NetStat, you could see all the services running in your Linux environment. So if you want to make sure your broker is running, I can see that it's up and running and I'm listening to it. This is the process and this is the port. Again, this is a no identification, so it's using the 1883 there. And I've also got some other stuff running on my computer, but this is a good way to look at all your network traffic and that services are running on there. And I'm also, it's useful to have my IP address. So I use IO config or IP config depending on your environment too, because we need to be able to connect to the broker. And so these are some handy Linux commands here to debug a system. And so for example, on my, I'm using a VM that's, and I have Ubuntu, I think 20 something, and I have a broker running on, and my IP address it's also important in an IP address. So I just IF config, and I'm connected to the Wi-Fi to NC State Network, and this is my address here. So there's different clients to talk, and this is open source. So there's it's implemented in pretty much any language, C++, Java, Python. And I'm going to show a Python example today. And there's a lot of this web apps or things you could just kind of download too for free as well. And so in my Windows store, I tend to use this. This is one of my favorite free ones, the MQTT Explorer. And then if I'm using my mobile phone to kind of demo something, I have an Apple iPhone, so I use the MQTT tool. And there's equivalent for the Android users out there as well. But I think I demonstrated that last class. This is the Windows free client there, and this is the one that's always running, and this is my local computer. And again, no username, password. I could have one. I could do encryption, and I could publish and subscribe to that man in the middle, which is the broker there, and the different types of things. And I am going to show that in a little bit later there. And I showed you some built-in mosquito command line, how to publish and subscribe as well last class. But the goal is to do some high-level language, not just go in your terminal and type here publish. This is subscribing to the topic. This is the name of the topic, and this is the IP address. And I'm subscribing to this temperature data that was on this public server called test mosquito. And we saw it on the actual browser too here using the client here. So we went through the publish and subscribe in the last class here. So this is new. This is actually a Python example that I kind of put together this morning. See if I can zoom in just a little bit more. So remember the protocol. You first just need to just pip install the MQTT, this version of MQTT, and I'm able to pretty much just import that, and I can make a publisher and a client in Python. Is as simple as those 2 lines of code there. You need to know your IP address, and this is the default port for the unencrypted. There's a keep alive, and if we was going to do some authentication to public keys, you can put it there. I'm not using it in this example, but there's just there. So all you need to do to connect to a client is just connect to the client here, and you need to define the client here and do a connect to the client here, and you're just going to pass in that host address and port name and everything else there. Here I am going to tie some callbacks to it. So when I receive a message, it's going to automatically call this unpublished, no message callback, and which I defined here. So when I receive a new message, I'm just going to print it to the screen here. And when I publish, I'm going to use this thing to publish. So I'm going to publish a topic to my MQTT, and it's going to give it a data payload here. And I'm going to subscribe to this topic. And again, I use a wildcard here, so I'm going to subscribe to any topic with the prefix ISE 589 here. And so I'm gonna got this already running. So I'm connected to my, this is out here. So I'm just going to run this example here, and it's going to subscribe, and then it's going to publish data. I'm using the JSON format. So this is the name of the field, and this is to be the value in the JSON format. And I'm going to, yeah, and then I'm just going to wait in this loop here for, if I receive a message, this callback on message is going to be called, and this is time my callback, and then I'm just going to print that message out here. So on my client here, the broker is running on my computer, and right now I don't have anything, any messages in my broker. I just started the broker up, and so I'm going to just run this, and I should have published the data field of non to my broker. And so you can see here, and you can see I have a data field of non there. And so it's just as simple as publishing something. So if I want to publish a sensor value to a network, or I want to publish, I'm finished with a process or something to start another process, you could just make a simple data here and then pass the address here. And if I wanted to receive something like, hey, let's start the system, let's stop the system, let's let's halt the system. I'm subscribing to this ISE 589, this topic, and I could, so this topic needs to be the same. And I'm just gonna put temperature, and I'm gonna make a packet. Again, this is fixed link, or doesn't, a variable length packet. And I'm gonna say temperature is equal to, let's say it's 80 degrees outside or something like that. And I'm going to publish that. And you can see it received the actual payload there. And the callback was called, and it's actually going to process that. So I am sending information to a man-in-the-middle broker with a quality of service of 0 here. I connected by default. And so it's not necessarily going to guarantee I got the information, but since it's talking to the same computer, it's not going to miss that information. But I could up my quality of service to guarantee that I got that message back and forth there. And so in the lab, we'll talk about it a little bit later, you're going to be connecting to a broker. You can be sending PLC data to the broker, and or you're going to start the PLC process using your phone. So I'm going to start a process. You're going to send the broker, and the broker is going to send the PLC, and the PLC is going to start the motors. So you're going to remote start and stop, just similar to the last lab, but you're going to use the broker instead of using the Modbus to do things there. So that's kind of the goal of where we're going with the lab. So we're going to go back to the slides. So this is just some sample code to get you started if you're interested in using Python to use MQTT there. And so this is the goal of the next lab, lab 4. I can use my mobile phone to start an operation on my PLC. So we have a broker in the cloud. You can either use the test or you can have your own broker running. I'm going to download one of the apps, and I'm going to send a message to it. The PLC is going to receive that, and it's going to start the motors. So I'm going to do a little bit of a cloud in the middle to do an operation there. And this looks a little bit more like the cell phone. I want to publish this particular topic to this PLC, and the topic is going to be called motor enable. If it's 1, the motor is going to start. If it's a 0, the motor is going to stop. And I'm going to toggle the motor, and motor is connected to the PLC. And you don't necessarily have to connect the motor. You can just get to show that that port is going high and active or going low. And this is what the next lab 4 is going to be creating this here. So the rest of these slides are just going to give you some information on how to kind of get started with the lab there. And the TA will be there kind of walking you through it as well. He has the sample code here and kind of get things moving as well. Any questions before I dive into the next phase? Right, so on the website, I put some starter code in this called sample projects folder. And this is a exported CCW file. So you need to make a new project and you need to import that. And I'll walk you through that in a second. And this is kind of how I'm grading that last project. So this doesn't matter what version you have, since it's exported, it doesn't matter what PLC, as long as it's the Allen Bradley 850 series, I can import that project and I can kind of move there. So import and export is the best way to send your project out to your customer, sending out the actual project itself. But this is you can download it from our course site and use that as a starter code there. Once you get it, your project, there's going to be a couple different blocks that, so by default, this 800 series does not support MQTT. I think the 870 series has it directly in there. So we're going to add these blocks to the 800 so we'll be able to operate and connect to the cloud over MQTT. And this is going to be 3 basic blocks: a connect block, a subscribe block, and a publish block. And these are user defined blocks. So that's what the UDFD stand for, user defined function blocks. And so you can save your code as blocks and use a higher level and then and as well. And that's kind of what we're doing in this session here. So we're gonna connect to a remote server, subscribe to that topic, and that topic is gonna be, in this case, this motor enabled topic. And if I receive this topic one, I want to start my motors. And then if I receive this topic with the value of 0, I want to stop my motor in the system. And we're not necessarily have to publish anything. You could publish your status to know that to verify the motor is on and off here. But in the lab, you're just going to receive and start the system based on the behavior of that packet going across the network. And these rest of the slides are going to be referenced to how they kind of get this thing going. So you will probably have to listen now, but you're probably going to revisit these slides next week when you actually do the labs here. And so this is just giving you information about each one of these parameters in these blocks. And it's to start off with the connect, and then we're going to go to subscribe, and then we're going to go publish. I'm not going to just read these out because you can kind of read them yourself, but I did highlight a couple of things that are important here. This here is going to be the IP address of the broker. And it doesn't take in like a host name, like test.mosquito. Or you have to have IP address like 192.680, blah, 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 in that format there. And so you can ping it and to get that information. And then you have to have a unique name when you talk to the broker. So you can have 10 threads on the system. Each one has to have a unique name so it knows where to send information back to. And so that is these are the two most important things that needs to be when you actually doing your configuration. And some of these other things are important, but just pay attention to the stuff in red. Will help you get through that lab, next week's lab here. And you could do a lot of different things. So you'll be looking at the status too, initializing. 9 is going to be important here. You want to make sure you connect it before you transfer, do a publish, because you're not really talking to anyone if you're going to publish to it disconnected. So looking at the status is important. So either 0 or 9 is kind of how you debug that. And then the name of the topic is going to be here as well. So if I want to subscribe to that motor enabled topic, you could type in a string there, motor enabled topic, and be able to listen to that topic there. So here is a screenshot here. I'm going to bring it up in a second too. But this is just breaking it down how to connect to your broker. Once you get it open, the project open, this is what it looks like here. And there's be a reset here. Remember, this is going to be function block enabled. So remember, if it's red, then it's enabled. If it's blue, then it's disabled here. So if I want to reset this, I could just right click and I could enable this block here. And this is where we need to go to here to set the IP address here. And this is where we give it the connection name here. So I'm going to just walk through that part, just kind of basic setup. So I have my new project, and I'm just going to throw something on the desktop real quick. And I have a PLC running in the other room, and it's the 850 series. This guy here, select, and start it up. And so the next stage, you have to import the project. So import, you will go to that website there, and you'll be able to download that particular sample project on the Moodle site here and get it. I have it saved on my computer. And this is going to load that project. So when I grade your last product, I'm going to import it, and I will be able to run your program and do everything here. And I can change the controller to whatever I need to do simulator. And so these are, remember, the URDF, the user-defined function blocks that we talked about early in the slides. It's actually using structured text here, which is my preferred language for more high level C there. And that's what you see. And here you have 3 user-defined function blocks to connect, to subscribe, and to publish. And this is actually their code here to connect, to publish, and subscribe. And I can use these defined blocks in my main code. And so I could make it like a subprogram, and I could call it a function, if you think about that as in a programming language. And I could call that sub function in my main program, and that's kind of what I'm doing here. So the main program is called MQTT, and I'm going to call these other functions here. So made a box for that, for each one to connect, publish, and subscribe. And here's the connect block here. Here is that enable. And I have global variables here for a lot of these inputs and outs. So I could set these here. It's either local or global variables. I think they are all pretty much all local in this case. And this is where I'm going to set some information here. And you need to set this before you actually connect to the device here. So the first important thing that I had in red was we need to make sure the IP address is set to the broker, and we need to have this minute username that's kind of unique there. So I want to, this local server and this client name is set to here and here. I want to be able to set this local variable to that. So that is a local server, which should be here. And you can see here's the port. We're going to use the default port. But this is where I need to set the IP address to my broker. And if you don't know your IP to the broker, I just use a ping to figure that out. So if I want to connect to the test, the mosquito, is it QITTO? And I could ping it, and I can see is that 91121. And that's what I want to put in here for my initial value. So this is 91.121.9394. And it will change. It's not a static IP address. It probably changes every day or something. So it happens to be the right. So I just connected before coming down here today. And also want to have a unique client name. So we'll find that here, and you want to change that to wherever your client name is. And I'm just gonna, as long as everyone's not using the same name, you will be okay here. So I just added some random numbers here to do that. And save this product. And I'm just going to connect to the PLC and upload it like normal. And I think it's this one here. We took a picture. Three, yep. And I'm going to connect to the PLC and then just upload a program to it. Okay, so there you might get this out of sync error, which is good. This is going to actually synchronize the time from your computer clock to this here. And now we're connected to it, and we went to the run there. And so if we haven't done this before, any of the calls, you could toggle those, force them by right clicking. And you can see you could toggle or use the control T to set that. So this block is connected because it's red and it's going all the way through. So this block is running. But we see here, I need to actually send the connect command to the system. So I need to also toggle these here values. So it should be a false, and then I want to toggle it true. And I should see my socket success go up. So it will not work unless you running a success is equal to none here. So that would be something you may run into later. So you may want to make sure this is false before and do a reset first. And then run the connect command. And you'll see it's connected to, remember, a non is a success. If you look through the documentation in here, and so that's what you need to. So I'm successfully connected to the public broker there. And now I could, so I'm looking at this status here to do different things. I can subscribe, I can unsubscribe, I can also publish, and I could, but I'm always checking to see if that success is equal before enable. So if we don't have a nine, you'll not be able to do anything there. So I just want to subscribe to a particular topic, and I'm going to look at this topic here. I want to subscribe to the command, and I'm going to move that into the command topic when I push it there. And then it's going to give me the value, the topic data is going to be located here. So I'm going to connect to that particular system, and I'm going to send, I'm not using JSONs at the moment, I'm just sending the raw value command as the topic, and I'm going to send the command as an integer 8. And then I'm going to publish that to this broker at that particular IP address. And if I want to subscribe to it now, I can right click here, toggle, and it's going to subscribe to the command in a second. And we should eventually get the number back to the data. Let me toggle this off. And so in the lab, you would kind of debug that. I got a small thing I need to fix in here. But you're going to subscribe to the motor enable topic. And if that topic is equal to some value, you want to turn the motor on. And if that topic is equal to some other value, you want to turn the motor off. Is how we get, is what's the goal of the, and you can use this as kind of starting point to complete that particular lab there. And then, so there is a little bit of tricky to get this working on this PLC because it's not default compatible with this. The better choice would be using the 870 series that has an MQTT block built right into it. And so in this example, the Modbus would be a better example for this particular system, but we're trying to force the system to do MQTT by adding a user-defined block there. And it's capable of doing that, but it's not going to be as nice, as fancy as using the some of the other systems there. And so this is all reference for next week, but that is kind of the lab. You're going to actually use your phone, or you can use this app here, and you can still send the message to the cloud, and the cloud is going to send it back to the PLC, and it's going to toggle the motor on and off there. And you can take it to another level. You can build an iPhone app or whatever you want to do to control a PLC, or send data back to a server and do some data collection using MQTT. And that's kind of, this is kind of just introducing the MQTT and the PLC environment for connection to. So this is all reference for next week. Just kind of walking through these steps in more details. Today I'll just kind of give you an overview and publishing the topics again. And this is what you want to have. You're gonna have plenty of time to actually dive in this on your own and make this project come to life. But this is the big picture goal. It's this here on my mobile device or cell phone or laptop computer. I want to publish to either a private broker or a public broker, and I want to send this topic to, and my PLC wants to subscribe to this topic, and I want to do some kind of behavior change based on that, receiving that topic over the cloud. And that's that's slide 4. Any questions on that? All right. Well, I will see you when I get back, and I will put this recording on the web too as well. All right. Yeah. Have a good day.